recording. So a little bit of review from what we talked about last lesson. Then we will go over an FRQ, that very first one from 2004 WordList. Go over some of the differences. It was a old FRQ and we'll update it. We'll walk through the rubric. I'll have the College Board rubric on one side of my screen and the answer key on the other side, and we'll go over the different parts and what the College Board is looking for when grading an FRQ. Then I will talk about some general information around the AP exam that you should be aware of, and that should bring us to the end of class. We save another rubric scoring of an FRQ, the second FRQ you're assigned to do on Friday, or due on Friday. Save that for Friday to talk about. Okay, so on to today's lecture, pre and post conditions. Helpful keywords. If you looked over the FRQ PDFs, you will see them very clearly laid out. They tell you that your goal is to meet the preconditions, have this function do blah. Then the preconditions are the parts of the code you don't have to worry about. Like, for example, assume that the size is always bigger than 1, or there's always an even amount of elements in your list, so on and so forth. You don't have to deal with things specified in the preconditions. All you worry about is achieving the post conditions. Then we have the return types. These are the guaranteed points on each FRQ. Look at what's after the public keyword and ahead of the function name. Create a variable of that type and return it. It doesn't matter the code that happens in between. You could do everything wrong. You'll still get the point for properly returning the type that they want. Notice that if it is void, that means it is nothing is returned. Okay, so on to the new stuff. So the FRQ from 2004 WordList is the very first year. Well, so 2004 was the first year the AP exam was in Java. Previously, it was offered in C++, and they changed languages then. With that change came a new set of FRQs, thus we have WordList. This is probably the easiest AP Java exam. They had to be kind the first couple of years so that they knew whether or not they're writing a good test. So this was the first FRQ you were assigned to do in Replit Teams, and we'll go over the implementation of 2 of the functions and how the College Board awarded points back in 2004. You should know that since 2004, the Java language has been updated. If you look up the solution to WordList back from 2004, it looks very different. So in this PowerPoint presentation, the code has been updated to match current Java. It's not the 2004 version. Mr. Simon mentioned something about back in 2004, they had untyped lists, or array lists, instead of typed array lists. You guys were like just born maybe around then, or little babies. I was graduating elementary school back in 2004. We were using like big iMacs that were just one big like monitor with a computer inside in the computer lab. Okay, this slide we can skip over. You're not getting the physical copy. You'll press the play button and test cases will run. But you should know that Mr. Simon and I are actively adding in more test cases to your Replit. As of right now, I think only the first FRQ, maybe the third FRQ has a couple test cases, but we'll be updating it. So definitely, if you finish your code early, run it again Friday, and expect to see some changes. You may not pass everything if you didn't address all the test cases. So the 2 functions that we will be reviewing will show the answers of the rubric side by side, and you can refer to it back on your own time. So Mr. Simon does this thing where he flips it upside down so that it's like a spoiler alert prevention thing. I unfortunately didn't ask for edit privileges on these slides, so we'll just have to deal with staring at this staring at the code upside down. So it'll look like this. Double check my recording. So if you're watching the video afterwards, just pause and turn it upside down so read it right side up. I unfortunately must read everything upside down for now. Here's my pencil. Double check that it is working. There's my. Not yet. Click, 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 click. There we go. It's working. All right. So if you already finished WordList, great. You should have gotten something similar to this. You can look onto this rubric and score yourself on how many points you would have gotten. I will grade it based on this solution on the right-hand side. So notice they look for a bunch of things. First off, they since they want an integer, darn it, why did it change? Go here, go here, go here. Why do that? That's kind of annoying. I tried to save some space. Let's just scroll this over. Make this smaller. Oh, sorry. You only see one screen right now, don't you? I have to reshare, I think. That's why. Okay, now you see two things side by side, correct? Thumbs up. Cool, thanks. Because I was clicking away and suddenly my annotation disappeared. I was wondering why that is. Okay, so you see the pink marks, great. Well, on the right-hand side, you see that flipped upside-down code. Bear with me on that. I don't have edit privileges to rotate the code. So notice here, right? They wanted a return type of an integer. So this person did exactly that. They created an integer here, count, set it equal to 0, and then returned it. So they got this first half points. Declare initialize count to 0. You could have called your variable a different name, but one job should have been to hold on to like how many words of interest there are, strings of interest. Must show evidence that the variable is used for counting or returns. So you got to do something like this part over here. Suggests that if you're not just returning 0, you're doing something to it. It's being updated. Next, they're looking for a loop over my list. Half point for it to be attempted and then half point to be correct. Nowadays on the AP exam, and I have slides on this later, they no longer award these half points. They're in like 1 point increments. So having a loop, for loop, while loop, what have you. Remember that in this specific problem, you were given something as an array list. And that's why this problem was asking for like the stuff as is, right? Because it's an array list. If it was an array, you could use square brackets and you would be fine. So right here, they have that for loop. Starts at I, ends at mylist.size. Size is reserved for array lists, and then I++. Another point, half a point here, get string from my list. Lose if array syntax is used. So right here is the part they're talking about. They do want you to distinguish between the array versus array list. In this case, mixing up square brackets versus using the .get function to access an element would have gotten you like half a point less back then. So you definitely should be using the .get function to access elements. Oh, squiggly braces, right. So because these things are written in one line, you could omit the squiggly braces. But you could add them in too. That won't affect, you're not graded on like, let me try to draw one upside down, right? Like usually after the for loop, we include a squiggly brace here. We'd include another squiggly brace here. After the if statement, to be extra clear, we added some squiggly braces there and there. College Board doesn't really care about that unless it affects the logic and flow of your code. they want to save space in their answer, so if it's just one line, they leave it out, and you can do that too. Okay, so that's there. Getting a little bit more complicated. Check length of string. So a key part you may have forgotten, some people often will have stopped like over here. Once they got the string, they don't do anything with it. Remember, the individual strings could vary in length, so you must check the length of each of those strings, which is why they awarded 1 point to get the length, do a comparison with the input that they were given. So a lot was going on in just this if statement here. Then, half a point for incrementing count. Oh, look, they did that. Good. And then must be within the context of length check. Cool. Lose this if count does not accumulate. So let's say they declared and initialized count inside their for loop. They would have gotten a point up here, right, for initializing it, but then they would have lost this point down here because it's a local variable. It keeps getting reinitialized and redeclared, so then it doesn't properly count number of strings of a certain length. Lastly, they return the count at the very end. As mentioned, that's like the easy point at the very end, half and half here, like 1 point in total. Pretty simple, pretty straightforward. You can see that you're awarded for doing lots of different things and getting partial credit. Like it's hard to get a 0 on these FRQs if you write something. Questions or comments? All right. If none, then we will go score this second part. Part B, you are expected to do a different kind of function while you are removing certain strings of a given length, I believe, from your array list. Once you hear remove an array list, the sirens in your head should be going off. You must watch out for the array list trap, and this rubric kind of addresses that. It says the word skip somewhere in there, so be careful when you are writing your array list code when removing things. All right, so as we break this up, again, this one was worth 5 points. There are half-point increments in between. Back in this old rubric, first off, we're looking for a loop over my list. Nice. So just like from before, here's their loop. They're using a while loop with good reason. There's your increment. There's their variable that counts inside their while loop. So good, they got that point. 1 for the attempt, must reference my list and body, and then 1 point for being correct. Must have an attempt at removal, must not skip items. Ooh. So this is kind of a loaded question. Must not skip items addresses the array list trap. Must have an attempt at removal, so that's like calling the remove function to delete elements. We'll come back to whether or not, or we'll come back to this 2-point thing while talking about the rest of them. Plus 1 point for getting the string from my list. Okay, so that should look familiar from the last question. Accessing elements in array list look like this. Can't use array syntax, must happen inside the loop. Then you check the length of the string. Cool, that also looks familiar from the previous FRQ. You compare it with length. Again, this, like writing just this if statement would have gotten you 2 points, right? Having just this if statement here written properly. 2 out of 5. Then we have this remove thing. They break into detail what this means. Half a point for attempting it, must call the remove function, must refer to my list or an index of an element in my list. So they did give you, like you would have gotten half a point back in the day if you used array syntax with this and did like my list square bracket I dot remove. half a point for that. So then the other half was using properly the get function. And notice here, back in 2004, you can get deducted for misusing array syntax here, and you can get deducted for misusing array syntax here. So then you get double deductions, right? Because it overlaps. This is no longer possible in the current way that the College Board grades FRQs. If you used array syntax once, you only get deductions once. They don't like double decrease your score, if that makes sense. Which is kind of nice. They're kinder with their grading in that regards. So here they list some things that are common that would yield minus points. So one is mixing up WordList versus MyList. In like the preconditions in the top, they gave you some variable names to work with. Make sure you're working with the correct one. Half a point for returning a value in part B, minus half a point for returning a value in part B, as the return type here is void. -1 for using this instead of MyList. Can lose a part in part A and again in part B for a max of -2. So this, it's been a while, we'll talk about it when we get to objects, but notice this line gives you an example of that like double deduction. You get penalized twice for the same error. Now you just get penalized once. Pay for it once, don't have to pay for it again. And then back commenting on this first 2-pointer, one for the attempt. It's really hard if I were a grader to kind of split this up. These other following points kind of describe this 2-point thing up here. In later weeks, we may have more examples of like partially correct code, which you can learn a lot from to see how the rubric kind of supports the in-between grades, right? Not perfect scores. Here it's would have been a perfect, this is a perfect score, like 5 points. It's the solution given by the College Board after all. But as you produce more and as Mr. Simon and I look for like imperfect examples, we'll post them. Questions? Double check the time. Doing okay. Got like 12 minutes. Are these FRQs like coding back problems, or will we need to code something like a GitHub project we've done? The FRQs are all like coding back problems. They are self-contained. Usually you have to write a function or two, and I think I have more slides explaining more about those FRQs coming up. They're short and self-contained. There are some, okay, since someone asked the question, let me jump down to like over here, right? So the FRQs you're given nowadays are aligned to like 4 different topics, right? You're guaranteed to have an FRQ on an array list, which is why we're starting to review with that one. They have one related to objects and class design, where you have to write like an object and probably use an object that you've written in the previous parts. That's the FRQ number 2. They have an FRQ on 2D arrays. Think back to like Game of Life, Minesweeper if you attempted it. And methods and control structures, this FRQ is the catch-all. Anything that doesn't fall into these other 3 categories gets put here. Control structures are formally like for loops, if statements, methods as in writing functions, like miscellaneous category. And the parts may relate to one another, but you won't have to write like asteroids from scratch or generate pretty graphics and whatnot. That's too much in the hour and 30 minutes you have to address 4 FRQs. So good question. This wasn't always the case. Back in 2011 when I took the exam, it was all random on the FRQs that they gave you. So they weren't as nice and gave you like topics you're guaranteed to have. I think my FRQ back in 2011 was like something about cards, and you're writing a class to model cards. You try to do a shuffle, you have to write a sort. It's pretty nasty. All right, so more specifics on the AP exam. There's two parts. If you've taken an AP before, then you're familiar with this. It's pretty standardized. If you're not, then be aware that AP exams typically have a multiple choice portion and a free response question portion, FRQ, both being an hour and a half, leading up to 3 hours. If we're in physical school, you would take that in the gym or in other big places. Um, People walk around. It's like taking the SAT, and there would be a whole different schedule to accommodate for AP testing, kind of. If you have an AP test, you would be excused from your classes. Now we just have it all online, May 18th, 1 p.m. You don't get penalties for guessing. The SAT used to do that, and maybe the AP test used to do that. So guess away. There's no risk involved. Yes. So AP Classroom is a resource Mr. Simon and I will be utilizing closer to the AP exam. We want to focus on the hard stuff, which is the FRQ portion. We will review a lot of topics by talking about FRQs, and in the 2 weeks before the AP exam, we'll really emphasize the shorter, I think easier multiple choice questions. And so progress checks and things could be assigned. You can do them at will. Mr. Simon has been not using AP Classroom as much because he has better resources for practice. Better, quote unquote. I think they're better. Okay, this thing gives you some emphasis that Java is a really big language. The AP test only uses a part of it, and everything we've taught you in this course is all you need to know, and all solutions for the AP exam can be done with this AP Java subset, like the Java code we did teach you. So this is the last time there was a in-person AP test offered, back in 2019. This was the score breakdown. The number of people that took it, almost 70,000, 324 readers. There's the split of 1 through 5s, the grades that you get on the AP exam after a curve. You can see that the majority of people passed and did well, with a global mean of 3.26. This is for Computer Science A, focusing just on the FRQ portion. So it's pretty hard to score poorly. Principles, if you're interested, their performance tasks look like this. Many more people took it, needed a lot more readers, much more variance in their FRQ or performance task grades. I think that's the big project you do. Maybe this was your year when you took the AP exam, Principles. Principles being the newer AP, I expect to see more variance. Also, many more people take it as it is beginner friendly, not like APCSA. So this thing, you can stare at it at your own time. They give you the breakdowns of the APCSA exam over the years, breaking down by multiple choice, free response, and composite, meaning the combination of the two. Generally, I noticed that people did better in the past on the multiple choice portion, and then it kind of evens out towards these years. Don't know what happened. I think, remember, over here, you see this dip, right? That's because they switched to Java, and teachers had to switch over. They had to, this was in C++. They were comfortable. Then they changed the language, and everyone was upset, so they did bad, and then they're adjusting, and then they did better. There's other stories you can tell from this data. I don't know them. I hope that Mr. Simon releases his lecture video so he can tell you those little stories on these numbers and diagrams. This one's kind of interesting. If you look at the score distributions, this is overall APCSA scores from recent years. 5s, 1s. A lot of people are getting 1s. I don't know if they're routinely doing better. I want to see more orange. It's kind of the same. I don't really like this graphic at all. It's hard to tell. They could have just drawn me comparing bell curves or something. That would have been easier. I think there's 2 peaks at 1s and 5s. How strange. Here's a giant list of common errors. Big ones that we talked about are this one, double equals and dot equals for string comparisons. Let's see. I don't even know what like this part means. Failure to use enhanced for loop when appropriate and use of enhanced for loops when not appropriate. I have that. This makes no sense to me. Uh, Failure to test for and handle boundary test cases. So this stuff is like addressing an empty list or maybe something that's too large, or you go like one index out of bounds, for example. If you don't address that in your code, then they could give you minus points for that. You can read the rest of these things. I can tell them to you, but really you need to see examples and be penalized for these kinds of errors to learn from them. Going forward, this doesn't really matter. If you were taking pen and paper, you could cross out stuff instead of erasing. In case you need to salvage code from before and you erased it, well, then you can't look back to it. You can't control undo with pen and paper. So cross it out instead. Oh yeah, for each, right. That might be enhanced. We didn't teach for each loop this year. I don't think you need it. You can see how kind they were in the AP exam grading. This is how they curved it in 1999. If you got 75% of the questions right back then, you got a 5. If you got 30% overall, you got a 2. 0%, you got a 1. So you had to actively try to get a 1 on the AP exam back in the day. And almost there. So nowadays, as I mentioned, there's no half-point increments. Each FRQ is worth 9 points in of itself. It's graded by hand, by a human. And Mr. Simon has years and years of experience with this, so I asked him to record his explanations of FRQs versus mine, because he's been doing it for so long. And I hope to get those videos out to you soon. Each of these FRQs have their answers posted afterwards, which is why we're able to make that Replit and recreate those FRQs in Replit and have you practice them. Okay, here's a giant list of other non-penalized errors. I think I showed you this slide before. Mainly, the main idea is syntax. If you don't obscure the meaning of your code through your spelling errors or type errors or symbols, right, then it is okay. Good example of that is like using the division symbol instead of the slash for division. If you use the like forward slash instead of the backward slash, like no points deducted there. They know you want to divide. You could even leave out semicolons and you'll be okay. If you're like writing this by hand, of course, like leave that out. It doesn't affect the meaning of your code. Cool. So that's it. That's all I have to talk about. You get to go 2 minutes early. Email me if you have questions. Grades are, for the most part, updated. Email me if you want things regraded. Formally, you're dismissed. Have a good one. See you later.